Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Hello students, I am Miss Suberi Favor. Welcome to mathematics class once again. Today we are looking at antilogarithm. In our previous class we looked at logarithm and how we can use the logarithm table to find the logarithm of basically the common logarithms. So today antilog is just the opposite of logarithm. Okay? Antilog is just the opposite of logarithm, just like the opposite of boy is a girl, the opposite of girl is given as a boy. So antilogarithm is the number corresponding to a given logarithm. Now in this case, you'll be given a logarithm and asked to find the antilog. You'll be given a logarithm and asked to find the antilog, just like your teacher can give you in the word boy to find the opposite girl. And you can also be given girl to find the opposite boy. So that is just the relationship between logarithm and antilogarithm. Now, if we are to find antilog 1.4316, if we are to find antilog 1.4316, that means we are to find the number whose logarithm is 1.4316. Okay? In this case, we are given the logarithm already. That we are to find the number who has this logarithm. So that is all about antilog. So log 27 is 1.4316. So we can say the antilog of 1.4316 is 27. Okay? So we are going to be looking at some examples. We are to find the antilog of 1.1761. 1.1761. Now we are to find the numbers of time. We have to find the numbers of time that 10 will be raised to have this. How many times has this been raised to get this? So that is all about antilog. Remember, we are working with base 10. So 10 raised to a power of 1.1761 will give what? That is antilog. So if we've succeeded in finding what it will give, then we've succeeded in finding the antilog. Also, we will have, what is the antilog? 3.0. Antilog of 3.0. Remember, we're working with base 10. That is how many, if 10 is raised to a power of 3, what we will have? That is if 10 is raised to a logarithm. Remember, we said in our logarithm class that logarithm means power. If this is the logarithm, what value will it give? If 10 is raised to this logarithm 3, what will you have? So that is the antilog. Now for better understanding, we will look at the antilogarithm table. Just as you always provided with the logarithm table, the provision for the antilogarithm table is also made. So when finding an antilog, we look up the fractional parts only, then use the integer to place the decimal part correctly in the final answer, the final number. Like in this case, we have 2.1547. We have to find antilog 2.1547. Now in this case, we are going to be ignoring this first integer, that's the whole part. We are going to ignore this part, that is the whole number, which is 2. Then we are going to be dealing with this part, that is the fractional part. So we ignore 2. The essence of this integer in antilogarithm is just to find the placement of the decimal number if you've gotten the final answer. So the fractional part is 1547. So we are going to look at the antilogarithm table. Antilogarithm table, we will find 15. We will look at locate 15 under x. Then we'll find the row headed 4. Then we'll find the difference of 7. So here, this is the antilogarithm table. The title is always given, antilogarithm of numbers. And we are finding 1547. So I'll come under the column x. I will locate 15 under this x. Then move straight this row to the column headed 4. Okay, 15, we locate 15 under x, then we'll come straight under 4, which is the third digit. Then, now the fourth digit, we will locate it by moving straight to the difference headed 7. So we'll find 15 under 4 and a difference of 7. As usual, we add the difference to whatever we have here under 4. Adding the difference to what we have here, there we have 2 at the difference. Then we add the 2 value obtained. This is what we got under 4 plus the 2 we got under the difference. We have 142. Now the integer part is 2.1547. This is what we got. This was the question we had. Now, and the integer part is 2. Now, according to the rule, these 2 we are going to add 1 to it. Then it will help in the placement of our decimal points. Remember, in logarithm, we count the numbers of digits we have in the integer part and subtract 1. But in antilogarithm, what we have in the integer part plus 1 will give the actual placing of decimal points in our final answer. So therefore, the antilogarithm of 2.1547 will equal 142.8. Alright, so from what we got from the antilogarithm table, we had 1428. And earlier we said we ignored the integer part, and there we had 2. Now, here is the work of the integer part. The integer part will only help in positioning the decimal point when we have the final answer. And according to the rule, 1 is always added to what we have at the integer part. So at the integer part we have 2 plus 1, we will have 3. That means I am going to count 3-digit numbers before I place my decimal point. So the antilog of 2.1547 will give 142.8. And also, if you are to look for the logarithm of 142.8, it will give us 2.1547. Okay, so we have another example. We can also make use of calculator to find that the antilogarithm of 2.1547. Now, in finding the antilogarithm, you will simply type 10 raised to the power of this. 10 raised to the power of 2.1547, and you'll be given the antilogarithm. Remember, in our answer we had 142.8, right? Now here the calculator is giving 142.79, and the number next to this 7 is a round up number, so we can always round 1 to the 7 to make it 8, which will be equal to what we had using the antilogarithm table. Now next we are going to look at how we can find the antilog of 1.2278. 1.2278. And we said earlier that we do ignore the integer part, then concentrate on the decimal part. For antilogarithm, we ignore this integer part. Its work is just for placement of decimal points. Now here, the fractional part is 2278. So we look at our antilogarithm table. To find 2278, we look down the column X and then stop at row 22. We looked at column X and stop at row 22, then we'll move to stop at the difference 7. So here, this is the antilogarithm table. I come under the column X, I locate 22 under X, then I come straight this row of 22 to the next digit, which is 7. I come to the column header 7 here, then I'm giving 1687. Okay? Now I head still straight, maintaining this same row to the difference part, headed 8. So I have 3 there. Then I will continue. I will add whatever I have in this under 7 plus what is given under the difference of 8. Then that will give, when we add 1687, which we got under 7, and we add the difference we got, which was 3. When we looked under 8, we had the difference of 3. We add, then we have 1690. Now we've succeeded in finding the antilogarithm. Now here comes the integer part we ignored earlier. I said its function is just for the placement of decimal in the final answer. So I'm not going to leave this way. There is definitely a decimal point. So here, the question, the integer we had then was 1. So we always add 1. Remember, in logarithm we subtract 1 from the numbers of digits we have. But in antilog we add 1 to whatsoever number we have in the whole part. So 1 plus 1 we give 2. That means I am going to move 2 place, then place my decimal point here. So the antilog of 1.2278 will equal not 1690 but 16.90, because I have to place my decimal point 2 digits away. Alright? So we can also use calculator to find the antilogarithm. Just 10 raised to the power of what you are given, the logarithm you are given. Remember, we said logarithm is power. And I said antilog is like the opposite of logarithm. Antilog is the opposite of logarithm. So the power which that base 10 number is raised is the logarithm you are given. Now the antilog is what will be the solution if 10 is raised to this power. So if you now raise 10 in your calculator, 10 raised to the power of 1.2278, and you press the equal to sign, it will give the antilogarithm of the digits. So we have 16.89. Okay? And in the solution, we said it's always in 4 figures, so you also round up so that you have 16.90. You can round up this 9 to 8 to give 9 here, and the rest we give 0. And in the use of calculator, we can press x raised to the power of this. That is when we have 10. When you type 10, press this. It will give an option of the power you want it raised to. So you type 1.2278. Then you equal to sign. Then you have your answer displayed. Alright, thanks for watching, and please don't forget to subscribe to our channel.